This is a really interesting question. We're taking a number, multiplying its digits together to give the next number, continuing this until we get to a single digit. We want to find all the different ways we can do it to get to 6. So I'm going to be working backwards in this case. So factors of 6, we've got 1 and 6, so we could do 1 times 6, which gives us immediately 16, or 61. And then 2 times 3, which gives us 23 and 32. So these could be possible starting numbers. We would just get a chain of just 2 numbers at that point. Now for 61, it's a prime number, so there's no way we can extend. And 23 is exactly the same, which leaves us with 16 and 32, which we could potentially get from multiplying other 2-digit numbers. It should just be noted that at no point can we get a 3-digit number because we have to start with a 2-digit number, the largest 2-digit number is 99, and that would give another 2-digit number. So as soon as you get, there's no way you could start with a 2-digit number and get a 3-digit number during the process. Because, for example, 16 could be obtained by 2 times 2 times 4, 224. But then once we times that, and that will give 16, but there's no way a 2-digit number could have got to 224 in the first place. That's just what I'm trying to explain. Okay, let's do this in 2 different cases then. So we've got, first of all, 16. Now 16 is 4 times 4, or 2 times 8, and that's it for the 2 digits. So I'm going to now try and do it kind of with different chains linking together. You can do it separately if you want, that's an alternative, but I could have 44, and that could actually be my starting number, so I'm going to circle it, or 28, or 82. And these could all be starting numbers. But I'm not finished with this because now I want to see if I can get 44 itself. But 44 is actually 4 times 11. So actually that's it. Cannot extend. It's not prime, but it's a multiple of a 2-digit number, 2-digit prime by another number. 28, however, is 7 times 4. That's the only way I can do it. So I could extend and use 47 or 74. Got another 2 possibilities here. 47 is prime, so we cannot extend. 74 is 37 times 2, so it's a 2-digit prime times another number, so I cannot extend this. 82 is 41 times 2, so again it's a 2-digit prime times 2, so I also cannot extend. Okay, but I managed to get another 5 possibilities. Let's do the same now with, what have we got left? 32. So 32 is going to be 4 times 8. Is that it? I think that is it, yeah. Or 8 times 4, of course. So we could do 48, or we could do 84, and get these as possible starting points. 84 is then 42 times 2, or 21 times 4. But this is then 3 times 7 times 4. There's no way I can get 2 single digits to multiply to give 84, so we cannot extend that. 48, we however can, because it's 8 times 6. Those are the only pair of single digits. So 86 or 68. 86 is then 43 times 2, so that's not going to be able to extend, so I've got another prime. 68 is 34 times 2, or 17 times 4, but again, a 2-digit prime, so I cannot extend either of these. And I've just systematically worked my way through to give another 4. So I've had 4 here, and then another 5, and another 4, which gives me 13 possible starting points. Just going to list them. And 6 doesn't count as a starting point, of course, because it has to be a 2-digit number. So the smallest was 16, and then we had 23. I then had 28 and 32. So that's all the one up to in the 30s. Then I had 44, 47, and 48. Nothing in the 50s, but I had 68, oh, and 61. And then 84, 82, 84, and 86. Oh, I think I've missed one. Got all of them. Oh, I missed out 74. Okay, and you could draw them as one big chain. In fact, I feel like doing that, so let's do it. We've got 6 as our end one, and then we had 60, 61, and we had 23, and then 16 gave us lots of different answers. 44, or 28, or 82, and then this one had 74, or 47. I think that might have been it for 16 because we had 5, didn't we? And then 32, which came from 48 and 84. And 48 just had this extra one because it was 8 times 6, so 68 and 86. So really nice way of mapping the whole picture. And it'd be interesting to find other, little mapping diagrams for other single digits. Well done on your efforts.